So some people are having some problems with this section in the VTVLC rational functions chapter, and so I thought I'd walk through a couple of these examples, a couple of these exercises, because the only way you learn to get good at something is by getting a lot of practice. So let's see how this works using this format. So let's look at a couple. Now see, these questions here are looking for a find exercise, find the asymptotes and the intercepts of these graphs. So I guess let's look at 24. So I know what you got to remember is that if I'm looking for the x-intercepts, any point along this x-axis is some x number, and y is equal to 0. So what I'm going to do is I'm going to take a look at this function here. I'm going to set the numerator equal to 0, because to find the x-intercepts, I really don't care about the denominator. With that said, there's an exception here, but we won't go there. So if I think about where does x plus 2 equal 0, I know that this graph will cross the x-axis at x equals -2. Then I've got to ask myself, how about the asymptotes? Well, a couple things to do. I'm hoping that when you work through the lesson, you came across and made the connection that all you have to do is look at the leading term in the numerator and the denominator, and then, because way out at infinity, if I plug in a million plus 2 is the 2 isn't really going to matter. If I square a million, the rest of it doesn't matter. So all I really got to worry about is x over x squared. If I reduce that fraction, simplify that fraction, that'll be 1 over x. And as x gets big, that 1 divided by a big number goes to 0. So this tells me the horizontal asymptote is y equals 0. And that'll always happen when the denominator is bigger than the numerator. If the numerators, now what if it's reversed? What if it was x squared over x? So the degree of the numerator will be is bigger than the degree of the denominator. Well, in that case, I'm actually going to simplify to x over 1. And as x gets huge, that goes to a big number over 1, which is just the big number, which is infinity. So there's no horizontal asymptote. Now, maybe we'll take a look at number 30 and talk about how to find that. Find the slant asymptote, oblique asymptote to call it. The only other thing I haven't talked about right now is how do you find what happens if the powers are the same, and this will come into play when you do the quiz. Here, let me clear all my drawing here. The same power. So what if I have something like how about something like number 27? That's probably one you had to do. So way out at infinity, the 2 doesn't matter, the 1 doesn't matter, the x doesn't matter either, because so I've got 2x squared over x, and if I simplify that expression, that's just 2. So that tells me the horizontal asymptote is y equal 2. So when the powers are the same, when the degree of the numerator is the same as the degree of the denominator, all you have to do is look at the coefficients of the leading term. So if there had been a 3 here with number 27, the horizontal asymptote would have been y equals 2/3. If it had been 7x squared blah 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 over 2x squared blah blah blah, that would have been the horizontal asymptote would have been y equals 7/2. Okay, so that's how you determine the horizontal asymptotes. If I want to find write a function for the horizontal asymptote of 1, I'll just make the numerator and the degree of the numerator the same as the degree of the denominator. How about this? X squared plus 7x minus 3. This will have a horizontal asymptote of y equals 1 because the leading terms both have a coefficient of 1 and they're the same degree. Okay. Now vertical asymptotes. So for number 24. We want to set the denominator equal to 0 because a number divided by 0 is undefined, and that tells me there's going to be a vertical asymptote. So what you do is you do x squared plus 2x minus 3, and you write equal to 0. And then you try to factor it, because factoring is certainly the easiest way to solve a quadratic equation, in my opinion. It certainly will help you out if you take AP Calculus. So that's going to give me, say I'm going to get -3 when I multiply this way, and 3x minus 1x is 2x. So we're good with x squared. So when does that equal to 0? That equals 0 at x equals -3 and x equals +1. So those are the two vertical asymptotes. Notice that I'm writing these as equations. Those are vertical lines, and that's where the vertical asymptotes happen. Looking at this function here, I know they're asking about limits, but what would the vertical asymptote be here? What would it be? What would be an appropriate equation for that one? So I hope you were thinking x equals 3. When x equals 3, I notice there's a vertical asymptote. So that tells me x minus 3 has to be in the denominator. Then I'm seeing a horizontal asymptote of y equals 0. So that tells me the x-axis, right? So that tells me the degree of the denominator has to be larger than the degree of the numerator. So since that's x to the first, this has to be a constant. I mean, without more information, well, let's see, we'd probably want to think about this. This has probably been reflected around the x-axis because, 1 over x, the graph of 1 over x looks like this. I'm hoping you get that committed to memory. And since this function has been reflected around the x-axis, I think we could put -1 or -2. I mean, yes, we could get a little more detailed, but we don't have enough points really to say. I mean, maybe it goes through the point 2, 1. I don't know. I think that's a stretch. This would certainly look pretty close to that graph. Okay, so vertical asymptotes in the denominator. Pay attention to degrees of the numerator and the denominator, and that should do it. One person on the test wrote on the quiz on this section, wrote an expression like this. They wrote 4x over 5x, and they had the question was, write a polynomial or write a rational function that has a horizontal asymptote of y equals 4/5, and this is what they wrote. This is really, really correct, and this brings up maybe one other thing I had to talk about. Well, I just remembered I got to do this too for the slant asymptote for you. Maybe I'll do that in a separate video. If we graph this on a graphing calculator or in Desmos, what we would see, we'd see, let's see, let me make something that looks about 5/4. We would see a horizontal line with a hole at x equals 0. And the reason there's a hole at x equals 0, not a vertical asymptote, is because there's a common factor in the top and the bottom. I could just cancel those off. But when x equals 0, I get 0 over 0. So I know there's an issue here. I can't just ignore that. So that's when you have a common factor on top, a common factor on the bottom. There's a hole at that point. Just to make sure you see this. What if we write 4 times x plus 1 over 5 times x plus 1? And yes, I left that all factored for you. What's the horizontal asymptote going to be? Where's the hole going to happen? So I hope you think in the horizontal asymptote is still 4/5 because the degree of the numerator and the degree of the denominator is still the same. And this is going to have a hole at x equals -1, because that's when the denominator is equal to 0, and that's when the numerator is equal to 0. So this would look the same thing here, except instead of being a hole here, there would be a hole at -1 right there. So that would not be filled in right there. And I don't know that I get a way to, a way to erase that. Let's see if I'll do it. No, I erased the whole thing. Well, you get the idea. Okay, so that's enough for this video. I'm gonna record another one here in a second that talks about how do you find the slant asymptote when the numerator is a higher degree than the denominator.